Assalamualaikum warahmatullahi wabarakatuh and good morning to everyone. Today, we will be introducing our model, the cooling tower. Cooling towers are essential structures in the industrial sector. This cooling tower model is fascinating because it's related a type of analytic geometry called a hyperbola. When we view the cooling tower shape from the side, we can see a curve that resembles a hyperbola. Now, let's identify the key parts of the hyperbola. The horizontal line is labeled as transverse axis. It passes through F, V, and C. The vertical line is labeled as conjugate axis. It also passes through the C. What is C? C is the center of the hyperbola, which is located at the midpoint O of the transverse axis. Next, there are two focus points. It is called foci. V is verticals. The points labeled V where the transverse axis meets the hyperbola. And the last one, we can see that the dotted line, which is labeled as asymptote, it is because the hyperbola approach the line with equation y equal to plus minus bs over a.
Materials that we use to construct the cooling tower are newspapers, plastic water bottles, cardboard, glue, and duct tape.
Why does a cooling tower suitable in hyperbolic shape? Firstly, to optimize the airflow. The wide base allows for the intake of large volume of cool air, while the narrow top accelerates the upward flow of hot air. This creates a venturi effect where the airflow is naturally drawn upwards, improving heat exchange. The shape supports this upward movement of warm air, allowing for more efficient heat dissipation. Besides, it's for the thermal efficiency. The specific curve of the hyperbolic promotes an optimal surface area to volume ratio, which helps maximize heat transfer between the water inside the tower and the air outside. The geometry allows the heated water to be exposed to the maximum amount of cooling air, enhancing the evaporation process and cooling efficiency. Lastly, to maximize structural strength with minimal material, the hyperbolic shape provides a high strength-to-weight ratio, meaning the structure can support its own weight and withstand wind or other external pressures while using less material. The curved design allows the tower to carry compressive loads effectively.
Deeper into this topic, we're looking at the question that we got. The question states that proves that the line y equals to mx plus c is a tangent to the ellipse b squared a squared plus a squared y squared equals to a squared b squared if a squared m squared equal to c squared minus b squared. First of all, we need to identify the equation that we get, which is this one, and we're going to put this one. Okay, so just take them out, then we got this equation and this equation. Okay, then you need to substitute the y in the first equation into the y in the second equation. Then you will get like this. Then you just need to expand them like usual. Then you just group them together like x squared with a squared. Then you will get this thing. Okay, after you just expand them, then you can see that the equation that we got now is in quadratic, which we can use the discriminant formula. For tangent, since it's only touch one point, then you need to use b squared minus 4ac equal to 0. Okay, after you decided to use the b squared minus 4ac equals to 0, then just identify which one is a, b, and c. After you identify that, you can see that this one is a, then this one is b, and this one is c. Then just substitute them into the equation for b squared minus 4ac. After that, just expand them like usual, then you will get this. To get this equation, what you need to do after this is you need to divide this equation with 4a squared. Just divide them. Then you will get this equation. After that, just finish them. You can just take them out since after you minus them, it will become 0. After that, you will get this equation. After you divide them with b squared, you will get this equation.